Right, so we want to look at integration today. Right, integration, it is the reversive process of differentiation. It is the process of finding the original function of x from the first derivative. So this represents from the derivative. Let's say we have a derivative. We want to find the original equation, the original function of y. So in short, we want to find y from dy dx, right? So general rule for integration, let's say we are given integral of x to the power n dx. This can be given by x to the power n plus 1 over n plus 1 plus c, where c is a constant of integration. Where c is a constant of integration. Right. So this is the general rule for integrating. On differentiation, remember we're subtracting 1. So on integration, we are adding back that 1. Let's take, for example, let's say we want to integrate x to the power 6 dx. By our formula, we say it's 6 to the x to the power 6 plus 1, or over 6 plus 1 plus c, which is equal to x to the power 7 over 7 plus c. That's for integration. So let's look at more examples on integration. Let's look at more examples. Right, example number 2. Let's say we are given integral of x times x plus 3 dx. This one can be written as integral of x squared plus 3x dx, which is equal to integral of x squared, that's x to the power 2 plus 1 over new power 2 plus 1 plus 3 times x to the power 1 plus 1 over 1 plus 1 plus a constant of integration, which is x to the power 3 over 3 plus 3x squared over 2 plus c. This is how we integrate functions of x. Let's take, for example, another example, number 3. Let's say we want to integrate integral of 7x cubed plus 4x minus 3 over x squared dx. So for your practice sake, you can pause this video, then try to attempt this question, then you resume and compare your answer with mine. This can be written as integral of 7x cubed plus 4x minus 3x to the power minus 2 dx, which is equal to integral of so now we are integrating each term. That will be 7x to the power 3 plus 1, that's 4 over 4 plus 4x to the power 2 over 2 minus 3x to the power minus 2 plus 1, that's minus 1 over minus 1 plus a constant of integration, right? Then we have 7 over 4x to the power 4 plus 2x squared plus negative times negative, that would be 3 over x plus a constant of integration. So this is how we integrate. Now let's look at another concept of integration, integration of the type ax plus b to the power n we are now looking at integration of the type ax plus b to the power n. Right, when we are integrating ax plus b to the power n dx, this one ax plus b will remain unchanged, but we add 1 to the power, then we differentiate ax plus b, we get a times new power n plus 1 plus a constant of what? Of integration. Let's take, for example, we are given integral of 2x plus 3 all raised to the power 7 dx, right? By the formula, we said that 2x plus 3 will remain unchanged, but we add 1 to the power, then we divide by the derivative of this function 2 multiplied by the new power plus a constant of integration. So now we have 2x plus 3 to the power 8 all over 2 times 8, that's 16, plus a constant of what? Constant of integration, right? Example number 2. Let's say we are given integral of 1 minus 3x to the power 5 dx, right? You can pause this video, then try to attempt again this question, then after attempting try to compare your answer with my solution. So solution, here we have 1 minus 3x to the power 5 plus 1 over derivative of 1 minus 3x is negative 3 times then new power, we have 5 plus 1 plus a constant of integration, which is equal to 1 minus 3x to the power 6 all over negative 3 times 6, that's negative 18, plus a constant of integration. Then this solution can be written in the form negative 1 over 18 times 1 minus 3x to the power 6 plus a constant of integration. So this is how we integrate function of the form ax plus b to the power n. Let us look at another example on this concept again. On this concept, example number 3, integral of 1 over root of 4x 4 plus 3x dx. So when we are integrating function of this type, firstly you have to rewrite this function as square root of as 1 over 4 plus 3x to the power half. We have to remove the square root first. Then now we can rewrite this using laws of indices as integral of 4 plus 3x to the power minus half, right, dx. Now integrating this type, remember we add 1 to the power, then we divide, where we have 4 plus 3x to the power minus half plus 1 over derivative of this function, that's 3 by new power, that's negative half plus 1 plus a constant of integration. So we have 4 plus 3x to the power 1 over 2 over half of 3, that's 3 over 2, plus a constant of integration. This can be written as 2 over 3 times, here we have, this can be written as a square root of 4 plus 3x, square root of 4 plus 3x, plus a constant of integration, right? So this is how we can integrate function of, let's look at one more example for the last chance. Let's look at one more example. Let's say we are given integral of 2 over 3x minus 1, 2 over 3x minus 1 to the power 6 dx. Right, so now we can rewrite this as 2 times 3x minus 1 to the power minus 6 dx. Then integrating this function again, we have 2 times 3x minus 1 to the power minus 6 plus 1, all over 3 derivative of this function times new power here, minus 6 plus 1, that's minus 5, plus a constant of integration, which is equal to 2 by 3x minus 1 to the power minus 5 over negative 15. We can rewrite this as negative 2 as a negative 2 over 15 times 3x minus 1 to the power 5 plus a constant of integration. Don't forget the constant of integration. So this is how we integrate a function of the type a, x plus b to the power n. So now you can try to attempt as many questions as you can using the examples that I just gave you. But don't forget, whenever you are integrating, remember I said we have to write the constant of integration, right? Don't forget this part. Then let's look at one more type, which is problems involving evaluation of the constant of integration. Problems involving evaluation of the constant of integration. Problems involving evaluation of constant of integration. Right. Now we want to find that constant of integration c. Let's take, for example, example number 1, the curve for which dy dx is equal to 2x times x minus 3 passes through the point, passes through the point, passes through the point 3, 6. Find the equation of the curve. Find the equation of the curve. Right. So we want to answer this type of question. the curve for which dy dx is equal to 2x times x minus 3 passes through the point 36. Find the equation of the curve. Remember, we said integration is the reversive process of differentiation, or integration is a process of finding the original function of what? Of x. So our solution here, remember we are given dy dx equals to 2x times x minus 3. Now we want to find our function of y. So our dy dx, by integrating both sides, remember integrating dy dx gives us y equals to, this one can be written in the form 2x squared minus 6x dx, expanding the brackets. Now our function of y is equal to, integrating this function, remember we add 1 to the power and divide by the new power. So we have 2x to the power 3 over new power 3 minus 6x squared over new power 2 plus a constant of integration. Therefore y is equal to 2x cubed over 3 minus 3x squared over, minus 3x squared plus a constant of integration. So this is the function of y. But now the curve passes through the point 36, which means our x is equal to, at point 36, our x is equal to 3, y is equal to 6. Now we want to find the constant of integration, which is c. Therefore y is equal to 2x cubed over 3 minus 3x squared plus c. Substituting 3 for x, 6 for y, we have 6 equals to 2x cubed over 3 minus, sorry, for x we are putting 3. That will be 3 cubed minus 3 times 3 squared plus c. Now we have 6 equals to 3 into 3 cubed, that's 9 times 2, 18 minus 3 times 9, that's 27 plus c. Now we have 6 equals to 18 minus 27, that's negative 9 plus c. 6 plus 9 equals to c. Our c becomes 15. Therefore our equation becomes y is equal to, from this we have 2x cubed over 3 minus 3x squared plus 15. Now we substitute 15 for c. This is how we find the constant of integration, right? So remember, you have to differentiate your function first, right? When you differentiate, so you have to integrate your function. When you integrate, you remain with a constant. Then you substitute the given values to find the constant of integration, right? Thank you. So try to look for many examples, so for your practice sake. See you next time.